Good morning.
Daniel, I have made you co-host of this Zoom session, so you should go ahead and put your slides up so we can all see them. Good morning, everyone. My name is Alan Exner. I am the ex officio for these proceedings today. We are here to hear Daniel Szelogowski's doctoral defense on his dissertation, Choral Music Generation, a Deep Hybrid Learning Approach. With us today, of course, is your chair, Dr. Susan Goodwin. Also with us today is our external examiner, Sophia Noir, Dr. Sophia Noir, and standing in for Dr. McAndrew, who's on travel today in Italy. We have the Associate Dean, Dr. Tracy Irish. Daniel, in a few moments, we will turn the floor over to you. You will have 20 minutes and only 20 minutes to make your presentation. At the end of those 20 minutes, we will begin a period of questions and answers. Your chair is here as your advocate and not to ask questions, but to help us in our deliberations as needed. The question and answer period will go as long as need be. We'll ask as many questions or as few as deemed necessary. After the question and answers, we will ask you to adjourn from the meeting while the rest of the defense panel deliberates on your paper and on your presentation. At the end of our deliberation, I will send you an email inviting you to come back so that you can hear the results of the deliberation. Is that clear?
Yes, sir.
It's customary for all the rest of us to turn off our cameras and our microphones solely for the point of not disturbing you in any way. So we will do that, and you have 20 minutes from now to make your presentation. Daniel, good luck. Remember to breathe, and hopefully you have some water nearby. The floor is
Absolutely.
yours.
All right, awesome. Thank you so much. All right, my name is Daniel Szelogowski. I'll be presenting choral music generation using a deep hybrid learning approach. My supervisor, Dr. Goodwin, and Dr. Paul Bodley, my SME from Idaho State University, I owe a great deal of gratitude to. They were extremely helpful throughout the whole process. I couldn't have done it without either of them. So despite significant advancements in AI and machine learning for music generation, there remains a notable gap in the creation of realistic AI-generated classical music, particularly in multi-voice compositions like choral music, where you have something like a complete harmonically and structurally coherent score, something that captures the intricacies and nuances of classical choral music that demands a high level of musical complexity and understanding. So this study aims to explore and validate the use of machine learning and deep learning architectures for generating musically realistic four-part choral music, thereby advancing AI technology in music composition and deepening the understanding of AI's role in artistic expression. So by examining existing research, assessing the capability of current AI architectures to produce compositions like human creations through a novel benchmark model, and analyzing perceptual differences in AI-generated music among individuals with varied music expertise, the study seeks to bridge the technological gap in AI music generation and explore its potential for creative enhancement in the arts. So this research offers novel insights into AI's role in creative expression, computational creativity, those sorts of things, and lays the groundwork for subsequent innovations in AI-driven music creation, examining the perceptual effects of my project's model and its capability to produce compositions that are indiscernible from human-composed music, both to musicians and non-musicians. So this study is thus intended for readers that have a strong background in computer science and statistical analysis, and at least elementary knowledge of music theory. So I have three major research questions that I focused on. Number one being, is there a current machine learning or deep learning architecture that's feasible for the generation of musically realistic four-part or SATB choral music, and does such a training set currently exist? Number two, can a hybrid AI model generate realistic choral music to the degree that the general public would struggle to differentiate from genuine human compositions? And lastly, number three, do individuals of varying musical backgrounds perceive AI-generated classical music differently than non-musicians? So for my literature review, I focused on kind of getting a broad overview of different models that I discussed with my SME before beginning the literature review, kind of getting a general idea of things like what types of models are being used for probabilistic attempts at generating music versus machine learning models versus deep learning models. So statistical learning, all of that through deep learning. So one of the first major papers that I found focused on using things like generative grammars, Markov models, hidden Markov models. And then in 2017, we started to see a shift towards using deep learning. The later of 2016, 2017 onward, that's when we started to see this big boom in AI architecture starting to really be used for generative, tasks like music and image creation. So 2018, we start to see people researching things like LSTM models, where we start to get into things that have a little bit longer term coherence, models that are a little bit better at generating lengthier pieces of music than just the kind of basic recurrent neural network. Kind of the more important papers here are from 2018 onward. We start to see this shift from 2018 onward into more sophisticated machine learning and deep learning models. The most important to my research specifically, and kind of the field in general, being Anna Huang's paper in 2019, the music transformer, that drastically changed kind of how the field works in general for people that are studying these sorts of things. All of the papers from here onward, on this slide at least, are more focused on the other two research questions that I posed, like computational creativity and music generation systems. The paper in 2020, giving just a broad overview of the current state of the art in the field, also a literature review of past models, and then a shift towards models that can, again, do long-term musical coherence. So all of these models from this point forward, from 2021 through 2022, when I began the literature review, they all, kind of switched to using either an LSTM-based approach or a hybrid approach using transformer models or transformer autoregressive models, which is the basis of where my research came into play. And again, all of these papers started to come up with the same exact problem, that most of these models that currently exist just as deep learning systems, they all struggle with long-term structure or long-term coherence or long-term dependencies. They all have kind of the same issues. One of the other papers that was pretty influential was Liu et al. From 2022. The SymphonyNet model was probably the closest modern paper to what I am working on, at least in terms of trying to generate something that has so many parts and such sophisticated harmony and structure and all of those sorts of things. And then the kind of most recent paper at the time that I found was similar to what I was attempting to do was by Neves using a hybrid transformer generative adversarial network model. So the research method used in my study combined quantitative and qualitative approaches, focusing on applying machine learning to create choral music and evaluating these compositions through surveys. This mixed method approach allowed for examining the AI's capability in music generation and an assessment of human reactions to AI-created music. So for me, the quantitative part involved training a novel deep learning model, what I call the choral-gtn, and analyzing its outputs, while the qualitative part used a survey to assess public perception of AI-generated music versus human-composed music. So my system, the Choral Generative Transformer Network, or GTN, uses a multi-layer transformer-based model, which is the GTN part, a MIDI generator callback interface, and a rule-based post-processing system, all of which were written in Python 3.10. The model was trained on a novel 1000 MIDI dataset that I dubbed Choral, which was something I had to curate specifically for this task because it unfortunately just didn't exist at the time yet. And Choral here stands for Choral Harmony Optimized Repository for AI Learning. The research design consisted of two phases. Number one, developing and training the GTN model on the Choral dataset, so training my own system on the dataset that I curated for generating 4-part choral music. And number two, evaluating the AI-generated music using a survey. The survey included a musical Turing test to collect diverse listener perceptions. Using this design facilitated a comprehensive study of AI's ability to produce realistic choral music and how different audiences perceive it. which aligned with the study's goal to demonstrate AI's potential in music creation, computational creativity, and explore its perceptual impact. So this design was based off of kind of all of the papers that did similar tasks in the literature review, all of the papers that were using like machine learning and deep learning based models. They were all using the same sort of setup, using this Turing test style approach of, is this AI, is this human, and using this subjective approach. So to me, that made sense. So other research methods or designs were not used because they might not have fully captured the study's aims. The approach that I chose, again, allowed for a detailed exploration of AI-generated music's technical and perceptual aspects. Other methods, they might have missed the depth of analysis needed to understand AI's role in music generation and its acceptance by listeners. So my focus was on balancing AI's creative capabilities with insights into human responses, guiding the selection of the methodology that I chose over other ones. In terms of data collection, my study targeted a wide audience, including music teachers and professionals, music students, amateur musicians, and general music enthusiasts. So this diversity aimed to assess AI music's perception across different levels of musical experience. The sampling approach combined convenience and purposive methods, including fellow teaching and administrative staff, a choral director and computer science teacher, university colleagues, and Prolific.com participants. Prolific is a service kind of like Amazon Mechanical Turk for human computation services. This method suited the study's exploratory nature, focusing on varied music perception. So I was able to, get a diverse pool of participants that had a lot of musical expertise versus some that had little to none, which was very helpful for what I was trying to go. Data collection involved AI-generated music samples and an online survey. So again, the GTN model trained on the choral dataset produced these samples. The survey was conducted via Pollfish.com and using Prolific to collect diverse participant responses. And this approach was designed to understand reactions to AI-composed choral music comprehensively. I wanted to understand, how are people going to react to these sorts of things as we go further into the future and can generate more realistic pieces of classical music, especially. In terms of instrumentation, the instrumentation for the analysis encompassed a comprehensive suite of statistical tests tailored to assess various aspects of the AI-generated choral music's perception. So I used a power analysis to determine the sample size's adequacy, ensuring the reliability of my findings. I did a power analysis and found that a sample size of like 360 something was enough to validate my findings. I had about 500 people, so that was sound to me. A chi-squared analysis was utilized to identify significant differences in the ability of respondents to distinguish between AI-generated and human-composed music. A follow-up Kruskal-Wallis test evaluated variations in response distributions across different levels of musical expertise. And post-hoc analyses, including additional chi-squared tests for the larger groups and Fisher's exact tests for the smaller groups, since chi-squared is not quite as good for the smaller groups. These were performed to further explore differences in perception across demographic groups and their associated opinions on music origin. So the analysis technique involved applying several statistical tests to the collected data systematically. Again, initially the power analysis informed the reliability of my study sample size to make sure that I could achieve statistical significance. Subsequently, a chi-squared test assessed the primary hypothesis concerning the recognition of musical origin, offering insights into overall trends. Kruskal-Wallis test then pinpointed differences in musical perception among varying expertise levels, highlighting the model's broad appeal or specific biases. And finally, post-hoc tests delved into demographic-specific responses, clarifying how different listener groups related to AI-generated music. All of these tests were evaluated for significance with a critical value of 0.05. So on the left side, I have this figure here that shows my survey demographics. Again, I had about 500 people. 41 were music teachers or professionals, 62 were students, 141 were amateur musicians, and 256 were music listeners, just general music enthusiasts. This obviously informed my choice of using non-parametric analysis methods, but also to me, This made more sense than having a kind of normally distributed data set or an equally distributed data set of all participants of expertise. This is, I would say, as a music teacher, more representative of the general population, having this, in this case, left skewed demographic. And then on the right side, I have kind of a heat map of my response distribution by the different demographic groups. So kind of just the general look of what the contingency tables look like for the analyses, where in this case, questions 1, 2, and 4 were my AI model, which you can see, most of which were 0.5 or greater, which means that they thought it was, in this case, they think it was AI slightly, like 0.61. They slightly think it's AI for music teachers, for example, compared to general music enthusiasts. And then questions 3 and 5 were human samples specifically. This was also really good for detecting any outliers in the data set because, well, I wanted to see, what would be the outliers for music teachers versus music listeners or general music enthusiasts, getting an idea of how is the different population going to see this data differently. So in terms of reliability and validity, the study aimed for high internal validity by standardizing musical sample presentation and survey formats. But the subjective evaluation of music introduces inherent variability in responses, impacting reliability. In terms of external validity, this is bolstered by having diverse participant backgrounds. But again, this is limited to an area of classical choral music and specific AI models. So efforts to manage these sorts of things within and between samples included using controlled variables, subjective measures, like I used a 6-point Likert scale, and randomized sample order. Although complete elimination of bias is challenging in subjective assessments. You're going to get a wide variety of responses when you're doing anything music, judging related. So again, the initial chi-squared analysis revealed that my AI model effectively produced compositions that were indistinguishable from human-created music with notable perception uniformity across demographic groups, except for one human-composed sample that was identified significantly as such. So this was visible in the graph over here, question 5, which was very obviously human. Most people realized that it was human composed as well. The Kruskal-Wallis tests highlighted variations in distinguishing AI from human compositions, influenced by musical background, especially for music samples generated from the weaker models, suggesting that, yes, music training affects perception. Post hoc analyses further validated these findings, showing no significant perception differences in the larger demographic groups across most samples, and indicating nuances detectable by musically trained listeners in certain samples, particularly from the least effective model. So these results to me underscore the AI model's capability in mimicking human compositions and the nuanced influence of musical expertise on music perception, reinforcing the model's potential in music composition and the complex interplay of music training in recognizing AI-generated music. For the research questions, this study explored AI's capability in generating, again, realistic SATB choral music, its recognition by the public, and the perception differences among varied listener backgrounds, for music backgrounds, I should say. So, number 1, findings confirm the feasibility of AI architectures for creating realistic choral music, evidenced by the hybrid AI model's successful deployment on a curated dataset. Number 2, this model convincingly mimicked SATB music's complexity, demonstrating advancements in deep learning and dataset availability. So this survey indicated that the general public with diverse musical backgrounds often could not reliably distinguish AI-generated classical music from human compositions, highlighting the model's proficiency. However, again, to research question 3, nuanced perceptual differences emerged, especially among those that have more advanced musical training, again, very clearly suggesting that musical expertise influences discernment of AI compositions. So these findings, to me, affirm AI's potential in choral music, highlighting its ability to emulate human creativity and the nuanced role of music training in perceiving AI-generated music. Overall, this study assessed a hybrid AI model's ability to generate SATB choral music, comparing it to human compositions. My analysis involved diverse participants, enhancing the findings' reliability. Statistical tests showed uniform perception across demographics, affirming the model's effectiveness in generating realistic compositions. Notably, certain musical nuances were more apparent to trained musicians, hinting that the AI has very sophisticated outputs, even to those that are classically trained for these sorts of things. Overall, the GTN model produced music largely indistinguishable to varied listeners, demonstrating AI's creative potential in music composition. In terms of contributions to the body of knowledge, this dissertation addresses a critical gap in AI-generated choral music, contributing a specialized choral dataset that I curated and the novel choral-gtn system. So I expanded upon the body of knowledge by blending advanced machine learning systems with music composition principles, achieving realistic choral outputs challenging for listeners to distinguish from human compositions. The study's detailed literature review and comprehensive analysis of music perception among various backgrounds also underscores the intricate relationship between AI creativity and human expertise, enhancing understanding in AI's application to musicology. For future research, people should explore expanding upon the GTN system and a choral dataset for broader applications, such as music education and AI-assisted composition tools. These sorts of opportunities include extending the model to support more voice parts, integrating instrumental accompaniment, and developing lyric generation capabilities, something that could generate complete choral compositions. This system could then be adapted for music composition software, like a Copilot style system, enhancing educational and creative processes. Research could also delve into incorporating emotional or thematic elements to produce contextually richer music for various storytelling mediums like film and video games. And lastly, this study sets a foundation for examining public perception of AI-generated music, suggesting further investigation into the ethics and recognition of AI compositions. That is all I have. Thank you so much. I'm happy to answer any questions that you might have.
If you would take down your slides. Dr. Irish, as the proxy for Dr. McAndrew today, we ask you to ask the first question.
Thank you. Daniel, thank you very much for your presentation. Very interesting work. The first overall question that we ask is, what is your original contribution to knowledge?
So my contribution, I kind of split up into three different things, one of them being the data set that I curated. There was nothing currently in existence for choral music generation specifically. There's lots of things for other tasks like instrumental music generation or piano music generation, like the music transformer paper that was published. That's what most of those papers previously focused on. So I curated the data set that I dubbed choral. I also created the GTN system, the kind of hybrid AI model, along with the rule-based post-processing system. That's something that I hadn't found other papers trying to do because, well, it requires a very high-level understanding of music theory. Having a rule-based system that can go through and correct sort of music theory errors was something that I felt that most music generation models were currently lacking. And then as well, the literature review, I did a comprehensive literature review to try and find like a chronological timeline of how has the field developed over time, where's the current state of the art, and what were people doing that worked the best out of all.
Thank you very much. I'd like to go ahead and ask a couple more questions before I pass it over to the external, if no one objects to that.
Please do.
In your survey, you said that you had 5 questions, which were really 5 samples of music for them to listen to.
Correct.
3 were AI generated and 2 were human generated. What other types of sort of controls did you build into that? Were they the same length of pieces?
Yes.
Okay, you didn't really talk. So can you explain any other kind of controls or variables that you had with that?
Yeah, absolutely. So I tried to make all of the samples about the same length to standardize them so they would all sound the same. I took the MIDIs of the actual, like the human composed choral music, as well as the MIDIs generated by my model, and I rendered them all using the MuseScore sound font so it would sound the exact same. I also presented at the very start of the survey before people would actually take it and start listening to the 5 samples. They were presented like a welcome screen, what is the survey on and, why. And then also I gave like a 10-second like intro sample, like here's what the all of the music is going to sound like all 5 samples, even the human ones will sound like this. So, that way they don't hear, well, yes, obviously this doesn't have text, so it's going to be AI. So I try to control, they all of the pieces sounded the same. They were all about the same length. They were all roughly 60 seconds. And then I presented them in a randomized order. I wanted to make sure that it wasn't all AI samples back to back or human samples back to back. I presented them in a randomized order that I thought would be kind of the best for, just getting something that would be uniform and something that I could use without having to shuffle the data, because I was worried that shuffling the questions, then people would get, okay, here's all 3 AI, here's all 2 human back to back. So I wanted to make sure that there was uniformity in how people would experience hearing these samples. And the Pollfish website was actually really nice for that as well. It required people to listen to samples all the way through. And then there was a survey code at the end for people that were using Prolific to take the survey. They were given a code only after they had listened to all 5 samples and submitted their survey link. So that was very helpful.
So they would listen to one sample and then respond to the survey question and then listen to the second sample?
Yes. Yep. And Pollfish requires that people, like if you present an audio-based question, it requires that people listen to the entire thing all the way through. So I didn't have to worry about people, okay, once I hear this, 10 seconds in, then I know for sure that this is AI. So that was really, really helpful to me in validating that people were giving, accurate responses.
And in the beginning of this, I didn't see you talk about this. Did you have any type of informed consent about your survey and how it was voluntary and people could stop at any point in time?
Yes, absolutely. And that was where I used mostly colleagues and fellow teaching staff and things like that. I said, here's the survey that I'm working on for my dissertation. You're welcome to take it, but by no means is it required. I filled out a special paperwork that I believe Dr. Goodwin signed for my school district to make sure that I got consent from administration to do research and all of that through them. And then through Prolific, I made sure that people also, it was an optional thing that they could just take it if they wanted to.
And finally, my final question is, at the end of your survey, was there an opportunity for any of your participants to give you any feedback whatsoever? Like, did you get their thoughts on AI-generated choral classical music?
I didn't put together a specific feedback form or anything like that. I didn't want to collect any sort of personally identifiable info. I didn't want anybody's emails or anything like that. I did get a lot of feedback from all of my teaching staff and colleagues and things like that, though. That's where I got most of the feedback was, in person and people that I knew from, working and teaching and all of that. So most of that is where I got the direct feedback.
Okay, thank you. I will pass it over to the next person.
Mm-hmm.
Thank you, Dr. Irish. Dr. Noir, your questions, please.
Sure. Actually, I got a few of them, but I'll say one of them was definitely answered by you taking everything and midifying to make the uniformity of it.
Right. That was one of my biggest concerns. I was like, if people hear a real composition, just someone's recording versus this AI generated sample, it's going to be super obvious right away. But I will say, if you're a musician and you use MuseScore 4, they have a new sound font that they've created over the last few years that's completely free. That sounds really realistic. I was honestly really surprised when I was developing the model and I finally listened to one of the pieces that was generated by the post-processing system. I honestly couldn't believe that it was something that my model had generated. It was really mind-blowing to hear. So to me, I thought that was an immediate success.
Let's see. Lost my train of thought for a second. I guess, has it been harder to do choral versus do you think other instrumentation?
Yes, absolutely. Funny you mentioned that. My very first, one of my first graduate classes that I took during my master's degree was my machine learning class. And for that class, we did a research project at the very end. The research project I did was trying to generate virtuosic classical music using deep learning models. So I used a recurrent neural network to generate. Do you know the Paganini caprices, the violin pieces that are like super virtuosic and things like that?
Yeah, because I used to be able to play Rhapsody on a theme to Paganini on piano.
Yeah. So I tried to generate the Paganini caprices, and then I had my friend who was a violinist perform some of them for me for, getting people to hear what they actually sounded like when performed on a real instrument. So this research for my dissertation was really kind of set in stone, kind of back when I started my master's degree, which was really cool to expand upon. And I had that set a lot of things in motion for, okay, well, what's wrong with AI generated music? Now that I've done a model, what's the problem? To me, it was, well, there's not really cadences. People that are doing this sort of research aren't really as much trained musicians, at least to the degree that someone like a music teacher would be. Someone that has taken, years of ear training and music analysis and music theory and all of those sorts of things. Because I mean, why would most people? That's a very niche thing. So for me, it was, trying to use all of this music theory knowledge that I had and figure out where are other people lacking and where are other researchers lacking in, developing these more sophisticated, post-processing systems that can make music that sounds and fits into common practice era methods of correcting music and adjusting for things like parallel octaves and fifths and making sure that harmonies are complex but still fit within a key or something.
So another question. Trying to phrase this right. When you say that things were discovered, like the people that were able to pick them out, that they are actually AI, was it like the cadence, the theory motion of it, of cadence and such and so forth, or lack therefore of, or was it I guess if it's all mitified, that I can't ask the second part of that question, because is it the execution of the instrument, or was it or was it purely theory based?
Right. Yeah, I totally understand that. I would definitely say part of it is that, because these MIDI files, they aren't usually, a lot of them aren't recording things like expressive markings, so you don't have things like rubato or accelerandos or fermatas and things like that are typically rendered within the sound font specifically. At least in newer versions of MuseScore, that has much more support with the new sound font that they have. But the MIDIs that I found didn't really have those markings put into them. And I also had to do a lot of normalization to get the data in a format that was very standardizable. I scrape a bunch of MIDIs together. I had to separate some of them out from the accompaniment that shouldn't have been there to begin with, or some of them that were intended to not have accompaniment had it. So I split them all into 4 different voice parts and then recombined them so I only had the voice part specifically. But in doing that, a lot of the pieces that had some expression markings inside the MIDI file, those were lost in translation. But other papers that I looked at again for my literature review for this, that's where more people started to look at, I think, the idea of long-term structure and long-term coherence. That was something that I also noticed. I think that was kind of what led my intuition of, there's lacking like cadences and, functions of musical harmony and chord changes and those sorts of things. Because most of these models, they'll generate like a start of a phrase, and then it'll keep going, and then it'll keep going, and it's the same phrase, and then it never really changes, or the harmony will slightly change. But it's still really noticeable that there's not clear breaks in the music or something that's very, very musical, something that actually gives structure to the music. I did my master's thesis on musical form analysis using AI models, and that was a problem that I ran into there as well. Was I wanted to find if I could make a model that could understand musical form, which, if I were to go back and expand upon this research that I did for my dissertation, maybe that's something I could use that model to guide, okay, I want this piece to be in binary form, and then I'm going to make it so there's a cadence here or something like that. Something where there's actually like fill in the blank structure that the model could follow. But that would be a lot of work for one person. I would need a lot more time for that.
Thank you for answering that. What was it that they noticed what was it that alerted them that it was AI? Did they comment on what specifically it was?
For this specifically, a lot of the people that I spoke to said that for them, if you listen really closely, especially for the people that went to the debriefing page, after they took the survey, I sent them to a page where here was the survey questions again, and there's like a little spoiler box where you can see this was AI, this was AI, this was human. They can actually listen to the samples again. Most people said, even the ones that they did get correct, they could tell just by listening closely to the harmony changes. There weren't very clear, structural harmony changes and things like that, like you would expect from classical music. You wouldn't hear like a very clear chord change, like this is a 5 chord going to a 2 chord or a 4 chord or something like that. It's not very clear in the AI generated music as it is in the human composed music.
But it's not clear all the time in human composed music. And
right.
That's
right.
Like, let me put it to you like this. So when I was young and I, sitting down in the piano room at a music college, he's like, my teacher who had the massive curriculum of how to technically wonder at a piano, he's like, show me something that you transcribed. And everybody usually shows a melody. I transcribed the weird section of It's About That Time from In a Silent Way, where a very unusual chord progression happens. That chord progression pretty much had never been played in all of humanity before.
Right.
It is a completely new system, and his exact words were, and he had Gary Burden as his instructor. That's the guy with Miles Davis. That's the when I was here at this school in 1969, when this was made, this wasn't in music theory. This school didn't theorize how Davis and Joe Zawinul and Chick Corea made that thing work until almost a decade later did it get incorporated into some kind of functional applied theory to know how to get back there. And since I heard that when I was young, like I heard that when I was 18 years, I'm going somewhere with this. When I heard that when I was 18 years old, it became the quest of people hit weird things. People hit weird things by accident in music, in the in either playing and or composition, that it doesn't have to follow any theory whatsoever. It just works because it does, and it gets incorporated in it. Sometimes people make a chord mistake and it'll sound better than anything they wrote due to a mechanical error.
Mm-hmm.
There's mechanical firing variants. No human is perfect at an instrument. It's like there's a humanistic output from it.
Right.
And that's where, I don't know, I hear AI stuff all the time. I'm just like, there's no leap outside of, like, I have a master of like theory, harmony, and air training, and with scholarship on that specific principle on its own. And I got to a point where, well, what's now? I've been there and back again with theory, and now I'm going places that don't exist. And the push of going where things aren't allowed is a part of why it sounds human, and you can almost find that in that little quality in almost everything we listen to, except for I sometimes think that they generated Taylor Swift's music background. Right. They just had her write lyrics and sing to it because it sounds trite to me. And even though I know people that probably are playing on tour with her as stage musicians, but in either case, how do you push the AI to I guess that's the question, in the more existential end, and that is, how do you push the AI to intuitively know when to forget how it knows anything and do something that is beyond that rule set.
Right. Yeah, absolutely. I think it's one of the most interesting things to me. I think AI music generation, there's so much to be done in the field, and especially for, all of the research that I've done and I've found and, heard in other people's works. Most of them, you can hear there's not a clear melody, or the melody doesn't interplay between the voices. That was for some of the people that I spoke to about my survey. They said, yeah, I could tell that there was a start of a melody, but it didn't really go anywhere, and it didn't go between the voices like traditional choral music would. Because I trained it on all like classical traditional style choral music, like 1600s to 1950s ish, common practice period style choral music. But you could clearly tell there's not a very clear melody between the voices. There's good harmonies, or at least sounds musically appealing, but there's also a lack of structure. And that was something that all of the other papers were talking about too, was you get this kind of like musical run-on sentence sound that, take it or leave it. It's good for the start. But what I found was most of the time after the first like minute or 2 minutes or maybe 3 minutes, the model would start to extinguish. I think it's just because of the way that the attention mechanism works in the transformer model. Even having multiple transformer models stacked, I was not able to get a model that could reliably produce music that sounded coherent past like the 3-4 minute mark, even after post-processing. It's the same issue that most of these other people were running into, with their own transformer models as well.
Gotcha. What's the goal? Okay, one last. I guess I gotta kind of wrap it. I have a lot of asks on this since like I'm sitting here with a drum pad.
Right.
Over this. What's the goal of this? I know to get a working. I know why what you're trying to do with the model. What's the end goal?
I think to me, the end goal, really, as someone that's in education, I'm a high school teacher. To me, I think that these sort of tools, we see things like GitHub Copilot and ChatGPT and those sorts of tools that are boosting people's productivity, especially where they might need just a start to an idea or something that can help them fill in the gaps and things like that. That to me is kind of the most important. Moving forward part of my own research is I would have liked to take this model and then turn it into something like a MuseScore plugin. So the model that I made, you can actually have it just generate music from scratch, which that's how I got the samples that I did for the survey. Or you can also give it like, I made a secondary, like a utility script that you could pass in a MIDI file and say, I want the first like 10% of this MIDI. I'm going to have the AI finish the rest of the MIDI from there, and then it generates something that's a little bit more coherent. So, if I were to make that into like a MuseScore plugin or like Sibelius or something, that's something that could then fill in the gaps of, okay, I'm writing this phrase for the sopranos, but what do I do for the alto part? Because I don't want the altos to just sit on one note the whole time, or I have this good tenor part, but I need a good bass line, or I have a good soprano and bass part, but I need 2 good middle voices. Something like that. To me, like I like music arranging. I think arranging music is really fun, but to me, composition is really difficult because I want to start and be, in the realm of, good theoretically sounding music and following, good practice and things like that to get traditional style music. But I have such a hard time coming up with those original ideas like other composers do. Whereas with something like programming, I can start a program and write out comments to myself of what I want it to do. And then, if I'm programming in like Python, turning comments into actual Python code is, it's about 10 minutes worth of work at most. It's pretty straightforward. Right. So it's much easier to come up with original ideas and turn them into something. But to turn something like this, like I have an idea for a melody, I want to turn this into a full choral composition. That would be really, really profound to me.
Gotcha. That's all I have. I think that's all I have for questions on this part of everything.
Thank you, Dr.
Thank you very much.
Daniel, just in the interest of full disclosure, I'm married to a choral director. My son was a vocal performance major in college, sang with 3 different opera companies. Made his debut in Carnegie Hall as a singer at age 17. I'm a semi-professional musician myself, and poor excuse for a composer. When the Ultra Gravis card came out in the early 90s, I had to build a computer that would actually, accept the card because it was different from everything else. Dr. Noir has seen my ARP 2600 that no longer works, but unfortunately, absolutely fascinating paper. But we have some questions that we need to ask. You talked about using convenience sampling to create your survey and purposive sampling. What are the advantages and disadvantages of convenience and purposive sampling?
I think to me, the biggest problem just in general is sampling bias. It's almost impossible to avoid. The thing that I wanted to do was get a sample that was as representative of the general population as I thought I could possibly get. That was the nice thing about using Prolific, was I could specify, okay, well, I've got a lot of people that are non-musicians. I want to filter out to only get respondents that are people that are, trained musicians or people that are at least studying music and things like that. So to me, I think those sorts of methods are good to the degree that, you can get something realistic enough. So for me, having the sampling bias, it's hard to avoid, especially in something as subjective as I think is kind of music recognition or music judgment and those sorts of things. The other issue that I ran into again is sample size. Finding a sample size for all of these different demographics, and also how do I decide, do I want something that's uniform or something that is something that would be good for non-parametric analysis. In this case, I had data that were left skewed and those sorts of things. But those were the 2 biggest issues that I could think of. But on the plus side of that, I still think I have data that's more realistic to what you would expect from, if I sample 500 people out on the street, I'm going to get a lot of people that enjoy music, some that are hobbyist musicians, some that are maybe studying music, and a much smaller population of people that are professional musicians. I think that at least was good in getting something that was representative of the general public, to the degree that I wanted something, that could answer my research question on, AI's perception and get an idea of, these people that are trained musicians versus people that are non-trained. How do they recognize this music differently? Because I think a good question to ask, from this sort of paper is, sort of the ethics of, how are people going to respect AI generated music, or how are they going to perceive it, and those sorts of things.
We'll come back to that in a moment. Tell me a little bit more about your how you developed your training set, your appendix that covered all of the pieces that you taught your model, everything from Copeland to Giraldi and quite a few things in between. What was the process of training? How did you introduce these pieces of music? Did you midify them first, or did you just play them? How did your training set learn what these pieces were?
Yeah, so I looked for open MIDI databases, things that were free. When I was doing my master's thesis, I found it really difficult to find good MIDIs of music that were good for analysis. But I found a couple good websites on like databases for choir directors on here's some pieces by Victoria, or here's some pieces by Bach or Brahms, and those sorts of things. So I found, I think, 4 or 5 websites that were good repositories of free and open source MIDIs. And I wrote some Python scripts to scrape all of them together and organize them. And I kept like an Excel sheet that kept track of do I already have this piece, or do I have this arrangement, or do I have this person's arrangement of this piece, or something like that, to kind of get as unique data as possible, but also as diverse as possible. between those 300-400 year time period. And then from there, I went through a lot of back and forth in trying to design how I would train the model on that. Initially, I tried taking like the normal machine learning approach and just turning it into something that was tabular. I tried to normalize everything as like an integer or like a float, and then turning that into like a Markov model. I tried Markov chains based on a suggestion from my SME at first. That worked decently well, but not very sophisticated, and I couldn't do much with it. I tried using the same approach that I took for my initial, master's level paper that I did on music analysis, and just using the actual MIDI data and then processing that as just note integers. And then I found the paper on SymphonyNet, and they did kind of the same process that I did, where they had all of the data as MIDIs, and then they took that and then encoded it in a format that a transformer could understand. In my case, I did it differently. They used byte pair encoding. I turned it into like strings of like, here's the soprano note, the alto note, the tenor note, the bass note, the soprano note. And then I repeated that process over and over again. And then I had a separate list that tied in the durations at the same point in time. So at each point that the MIDI or that the transformer is being trained, it's saying, here's the soprano note, and its duration, here's the next alto note and its duration, tenor, bass, and then it repeats that cycle the whole way through. So it has two separate input channels and then two separate output channels as well. I found that to be extremely effective. It was the only thing that really, really worked really every time, versus all of the other models that I attempted in between, like HRED models, RNNs, GANs, LSTMs, biaxial LSTMs. I tried everything under the sun to find something that would be good, which is why initially when I was doing the proposal for the dissertation, I knew that this is something that was going to have to be a hybrid system. I knew it was going to have to incorporate, I'll have to use a deep learning model to do the music generation because that was my goal, but there's no way that I can also get it to do the corrective aspect. That would be better for like a decision tree or like an optimization model, or in my case, a rule-based model.
How long did it take, to train your model?
Oh, a long time. Probably
Months?
the most time. I think I spent I collected all my data mostly during the summer, and then around late August, I started working on the program. I was working on models constantly for about 5 months straight, from like July-ish to right at the beginning of December. I had something that I thought was like as perfect as I would get, something that I was at least happy with. But I was trying all of these different models. I tried a million different formats of, integrating the music into the model. I tried different, tablature formats versus, stringified formats versus, heterogeneous data versus homogeneous data. I tried everything that I could think of, and the one that I landed on finally stuck. I think the thing that I kept coming back to was all of these other models that I was trying. In the end, the transformer ended up being the best one out of all of them anyways. So even though that was my initial approach that I wanted to not do because I didn't have a good understanding of transformers at the time, now I'm intimately familiar with them. But coming back to them now, I can see why people are using them for, trying to push the field forward. They're really, really good for what they do.
What were the two human-composed pieces of music that you played for your survey?
Let me see. I have them in the appendix.
I didn't see it.
It's
probably there.
It's on page 225 and 227. John Bennett's "Oh Sweet Grief" and Thomas Victoria's "Benedictus Dominus." And then for like the intro sample, I played the introduction to Fauré's Requiem for like the 10-second snippet of like, here's what the music is going to sound like.
Okay. I got it. I missed that completely. Couple more questions. In your future research, you talked about the ethics of AI-generated music. This past year, we saw, the creative community go on strike for 6-7 months, something like that, mostly affecting television and motion pictures, over their concerns about who gets paid.
Right.
If artists are replaced by artificially generated, do you feel your study has an element of controversy, or is this? I got a hint in how you answered Dr. Noir that what you're looking for is something that can perhaps be a better arranger of an idea that you have. And I'm intrigued by that. So which is it really more? The origin of completely new pieces of music that have never been created before, or something that can make a much improved arranger?
Right.
In your
Yeah. So to me, tools like GitHub Copilot are some ones that I've been kind of studying as I've been using them. So, having this tool that I can start writing a line of code and then it can help me finish either that line or like the next 10 lines, sometimes like the next 30 lines. I think that's incredible. And to have something like that for music would be great. I think for people that are in, the creative domain, that is something that, if you're just getting, creative burnout, like if you're a composer and you're trying to work out, new compositions to make a living, but, you're stuck on an idea or you're stuck on, some part of a composition, having a tool like this, I think would be really beneficial to finishing that piece and then moving on to the next one. Or even, I'll generate a melody using an AI and then I'll fill it in myself. So I think there's room for both. But again, there's also the problem of, well, just like GitHub Copilot, I can say, just write this whole program for me. Or with, in this case, my model, I can say, write this whole piece for me. Then, it comes down to like, if I were to start, pumping out compositions left and right, I had 100 new compositions and I go to Hal Leonard. I tell Hal Leonard, hey, here's all this music I made, can you publish it? That's where I think there's room for a lot of discussion on the ethics of something like that, because I could do none of the work and publish all of it, or I could do most of the work and have something that can help me, finish my creative ideas. So I think just like, with ChatGPT and Copilot and, these image generation systems, I think there's a lot of room for a discussion on the goods and bads and ethical usage. And I recently did a conference presentation to the other computer science teachers in Wisconsin just a couple of weeks ago on integrating AI in the classroom. And I had the same kind of discussion with them of, if you're going to use this, students can use it correctly without doing all of the work for them. But you also have to set that you have to set that model for them and show them how to do things, in a non-plagiaristic way. And, all of that. There's a lot of room for discussion. I think that's another paper on its own.
Undoubtedly. Yeah. My classical guitar teacher when I was in high school said, everything that has been composed, everything that could be composed has already been composed. And anything else is just variations on something that already exists.
Right.
And if I had a chance to track down my teacher today, I would have to ask him, how he thinks AI changes that. Well, at any rate, fascinating discussion. We could do this for another couple hours. Daniel, if you would adjourn from the meeting, we will deliberate. Your chair had a previous engagement at work, so she had to drop off, but we will struggle without her, and we'll call you back in just a few minutes.
Perfect. Thank you so much.
Thank you. All right. Daniel, welcome back.
Thank you.
We enjoyed your presentation. I'm going to turn the recording back on for
recording in progress.
Thank you for coming back. We very much enjoyed your presentation and your paper. I have a very short list of some grammar corrections. It's amazing how difficult it is to get Word to properly identify. I would have to create a whole new dictionary for it not to reject all of the the words and phrases that I'm familiar with that clearly Word does not know.
Right.
Nor the split infinitives. There weren't enough of them for me to go into any harbinger about that. But it's a very short list that I'll send you after we finish with this. But we have a few changes that we want you to make to Chapter 3. Mm-hmm. Specifically, we would like you to add some more information about your participants and the survey. Because it was very clear in your presentation, but we thought that in your paper itself, we wanted to know more about your survey. For example, like your controls. You told us in the presentation that there were 60-second modified, and I'm not sure that we found that as well stated in your paper. The fact is, your survey answers, your 2 research questions, but we felt as though you didn't quite. You could have had a quantitative study just based on, the work that you generated, but you chose to make your paper a mixed method paper, and I think that there's more that can be said, not more than a few paragraphs probably, about how your survey was derived. Like I say, you addressed all of this quite well in your presentation, but people won't have the advantage of coming back and necessarily talking to you, and I think that people will be a little bit curious as to how you did the survey portion of it. We thought it was an excellent survey, but how one of the specific things is you talked about how you randomized even what pieces, not randomized, but you were careful not to put human compositions with AI compositions in a predictable, or just if you would clarify how you did that in the survey. Make sure that it says, was it different for each participant, or was it exactly the same? Just a couple of details like that. Am I highlighting that, Dr. Irish, the way you meant for that to be?
Yes, I mean, you reference the survey in an appendix, but you really don't go into much detail in Chapter 3 about the survey. And since that is, the source of your data for answering 2 of your research questions, I think that it deserves the attention in Chapter 3, where you tell us more about how you designed the survey, and how you intended to administer your survey. How, and I think you did talk a little bit about how you found your participants, but make sure you talk about all the different, the pollfish and the prolific and the design of the survey a little bit more. Don't make the readers go to the appendix to find that information out. The other thing throughout the paper, you call your survey as a pilot. And a pilot is typically what you do to sort of test a survey. You send it out to a very small group of people to pilot it, to make any modifications on the survey before you send it out to your total population. So I don't believe you did a pilot. I believe that this is your survey. This was your data collection instrument. So I think that you need to kind of remove the language about doing a pilot.
Right. Yeah, absolutely. Yeah, and then I thought I covered all of the stuff that I discussed on the survey design. I believe I tried to incorporate all of that into Chapter 5.2. I believe covers all of those things.
But in Chapter 3, where you're talking about your methodology, you hardly mentioned your survey at all.
Not the rest of it. Yeah,
it's right. In the appendix.
You did explain it with your results, but not in the definition of your methodology.
Right.
And once you've made those corrections and those few changes, send them to your chair. And after Dr. Goodwin's had a chance to review that, she'll forward that to us. We will see that the changes that we requested are made in case there's any misunderstandings. And once that is done, we will go to the registrar and ask for your degree to be conferred. So congratulations, you're 99 and 44/100% of the way there. As always, many thanks to Dr. Sophia Noir as the external today. Sophia and I have a long history of working together on a variety of different topics. Her background is far more varied than you could possibly imagine. Not only does she know an extraordinary amount of music, she's also well-versed in safety culture and in aeronautics and in weather. It's just, she is the master of all topics. And I specifically asked Dr. McAndrew when we got a hold of your paper if we could include her as part of this, because we knew that this would be something that you wouldn't be able to fool her with anything, because
Right.
she would be able to, and she has high praise for how you got to where you got. Many thanks as well to Dr. Tracy Irish. She's a relatively new, well, you're not new anymore. You've been here for almost 10 months at this point, but a valuable part of our doctoral team. And Daniel, we thank you for your work. We also want to thank your chair for obviously doing a terrific job. I know she felt quite comfortable working with you in this, as this is very much in her wheelhouse as well. So with that, I'll say thanks to everyone and enjoy the first full day of spring. And we'll be looking forward to seeing your changes back. I'll send the feedback form to you within the next 30 minutes.
Yeah, I will get on those right away. And then for the registrar stuff, do I still need to go through like finishing the rest of like the check-ins on Canvas? Because I'm technically enrolled in the last.
You do need to finish the classes, but that we'll still put in as soon as we get the changes back, we'll put in the recommendation to the registrar to confer your degree, which should happen, I would imagine, Monday or Tuesday next week.
Right. So still go through the stuff in Canvas, just knock it out.
Yeah.
And then, yeah.
We have other people we have to make happy.
Right.
All right.
Absolutely. Thank you so much.
It was a very interesting read. I really enjoyed it. Thank you very much.
Thank you so much.
Congratulations, Daniel. Thanks,
Yes,
everyone.
congratulations.
Bye-bye.
Thank you.